modules. So let's talk about account security module 2. All right. So the first thing that happens when you ask for access to a service is you either log in and give a username and password, or someone supplies credentials to you, right? It's like, hey, I want to try your service. It's like, okay, give me account credentials. How do I get in? Okay, so that's what we're going to talk about next, is how do we get account security on our AWS account, and how do we design for that security? Now, check-in wise, one of the first questions they ask is like, how many accounts do you have? Now, considering who you work for, I'm going to tell you right now, it's going to be more than 10, right? So now your individual clients, they might have 1, they might have 4. Some people use what's called a multi-account strategy, where they isolate every single project by its own account. And that includes whether it's project A production, project A development, project A staging, which is a great way to do it if you can support that and you have tools to manage the like many accounts are going to arise in that context. But it also makes billing really easier, because while tagging is still supremely important inside of any AWS account, when you do a multi-account strategy, you know that everything in there goes towards this project and this environment. Some people do that. Some people do a multi-VPC strategy, where they create multiple networks inside of a single account. Most actually do a hybridized version, where it's both, right? So let's talk about account security. Now, the stakeholder feedback is mainly about security for this, right? Because, we want to understand how we can grant different access, permission sets, basically. How can we implement single sign-on? Because we also want to make it easy for security to function. And then how do we manage multiple accounts? If I got 700 accounts, how do I manage that, enforce compliance, restrict access to certain types of services? How do I do that? So then what are the best practices here? How do I follow the principle of least privilege and only give them access to what they need? How do I grant temporary access to resources? Which, by the way, AWS has a very specific perspective on what they call granting temporary access. Just remember that I said this: roles, okay? That's Amazon's perspective on this. And then what's the best way to manage multiple accounts? Those are the questions we're going to go after. Now, there's usually 2 steps in a process. There is, how do I verify you are who you say you are? So authentication. And then there is the granting, like, what can you do once I know who you are, which is authorization. Now, in AWS, the way this works is that you've got permanent users, and they're not called permanent users, they're called users. And they are typically part of groups, and there's policies attached to these groups. And then what happens is that these users then get permission policies, and they can actually do stuff to the services because the identity of the group or the user has a policy attached to it. That's called an identity-based policy. The other entity, though, is that Amazon says if you want to grant either a person or a service temporary access to something, you can elevate their privileges like a sudo, right? Or what's the Windows administrative access control system? The one that says, hey, are you sure you want to run this as an administrator? It's the same thing with roles, is that a user can assume a role. What's cool also is that a service can also assume a role, and a role is nothing more than a security identity. Think of it as a security disguise in some ways, right? And so you might not have permissions to create users, but if you step into your administrative role, you then get access to create users. So we're going to talk about those. So we're going to talk about the core security principles, which I have a little bit of a difference around this than Amazon does. Then we're going to talk about policies. And then we're talking about how to federate IAM with external systems like Active Directory or Okta or Ping Federated or whatever. And then we're going to talk about how to manage multiple accounts, which is really just revolves around the service called organizations, right? So as you said, Christian, it really is kind of like role-based access control, right? They have an identity, right? And so how can we then grant them a role that would then allow them to get access to the systems in question? So security principles, user story. So we got a new team, need to use the development account. How do we create a repeatable process to provide access, right? Now, the first thing we're going to talk about just in passing is the root user. The root user is what you create when you create an AWS account. Typically, what you do with this account is that you log in with it, create an IAM user, which is what this is, and then that IAM user creates all the other users. But just so we're clear, the root account, how do you identify the fact that you're using a root account? It's because if you use a root account, your username is an email address. Do not log in with the root account. Don't do it. Now, there are going to be situations where either through Amazon or otherwise, you're going to have to log in as the root account, but that's a like emergency or special exception. As a general rule of thumb, do not use your root account. The reason for that is that, especially if your account was created after like September 2017 or something like that, you cannot restrict this account in any way, shape, or form. So if your account was created before like Q3, Q4 2017, you can't restrict this user, even with organizations. If you created your account after, I think it's like Q4 of 2017, if memory serves, you can restrict this using organizations, but only if you use organizations and only if you explicitly restrict it. So this is a dangerous account in that it's necessary for account creation, but you should really ideally don't use it. I literally watched a company go out of business. It was one of the contributing factors for a company going out of business because they left their root user keys inside of a repository that everybody got access to and was shared to. And then somewhere in year 7, after this repository was available to every developer, someone went in and decided to delete the non-production environment. And it was one of the factors, not even necessarily a major factor, but it was definitely a factor in that company going out of business, right? So bottom line, don't use this for anything other than initial creation. Other than that, you're going to use IAM. Now, IAM users are like, this is a free service basically inside of AWS, right? So if we go to the console and flip over, assuming that Michael can actually have his console up, and we go in to IAM, this is free, right? And then over on the left-hand side, what you're going to see is you're going to see users, user groups, and roles. Underneath that, you're going to see policies, identity providers, and then a variety of account settings, right? So the idea here is that you can either have users, user groups, or roles that can have policies attached to them. Policies is right at the bottom. Now, IAM is where all this magic happens. This is to control access to AWS resources only. Let me be super clear about this. Typically, if you are starting an operating system or a database system or a Kubernetes system or some other system, you cannot natively use these tools to manage the users inside those systems. So IAM is typically not used to log in and authenticate into an operating system. You have to use like what's called an EC2 key pair for that. Or you use the PAM, the database module that's inside the system. Now, that being said, you can federate those systems. You can figure out how to extend, your operating system to use IAM. You can figure out how to extend your Kubernetes system to use IAM to log in. Okay, so you can figure out how to make that happen. Even your database systems, like RDS, for example, now has a checkbox that will allow you to log in using your IAM users. But this is really not for application user databases. Like this isn't. So like you're going to create this for your web or mobile app. This is really just for AWS access and some of the subservices that AWS creates. Now, the principles for this are a user, a group, and a role. And to be clear, users are really one-to-one with an actual user. Sometimes users can be applications, especially if they're off cloud. Roles are assigned to either users, like users can like assume the role, or an EC2 virtual machine could have a role, or a Lambda function could have a role, right? So services in AWS can also assume these security disguises, these roles, right? So now notice also that an identity provider can actually come in and assume an identity, right? Mainly as a role, right? So just so you know, if a third-party provider gets put in, you're either going to create a service account or a role that's going to get access into this, system, right? So there's entities here that can be used depending on who you're connecting to, right? Typically, if it's a real user, I'm going to have a real username, right? And they might have one, and they might have 50 roles to get them access to 50 accounts. So also be mindful that you might have one user in one account who is connecting to roles that are in 50 other accounts. And the reason you do that is so that the user doesn't have 50 username and passwords. They've got one username and password, and they assume a security identity in these other accounts. So that's what roles are for, is to grant temporary permissions. So here, other than the root user, you've got administrators, developers, auditors. You can attach policies directly to these users. That's not best practice. Best practice is that you put these users into an administrator group, a developer group, an auditor group, and you attach the policy to the group and then put the user in the group. This is no different than the way we've been doing Active Directory and all other services for 30 years now, or maybe 20, 25, maybe 30. Now, when you interact as a user with any of the three ways that you can talk to AWS, there's actually two ways to do that. One, if you want to log into the console, you have to have a username and password, right? You're logging into a web interface, you have to have a username and password. For CLI and SDK, if you want to use those, which are mainly command line driven, even the SDK is command line driven, right? What's going to happen is that underneath the user, you have to create an access key and a secret access key. That's basically a username and password. It's just this long alphanumeric, right? And you have to actually put that into a configuration file of some type, a credentials file to be specific, right? You put it in a credentials file, and that credentials file will be used when you run the command line tool. It'll be used when you actually run the SDK. Now, don't get me wrong, you could hard code that into your like Python code. Don't do that. Please don't do that, right? Do not put credentials in the repository, okay? Keep it outside of that. Use the AWS CLI mechanism and just, let that pull its credentialing, right? Now, you can delegate different permission sets by basically calling out the verbs that you want to grant to the user in question. So when you're defining policies, you can attach policies with explicit actions that those policies grant. So the policy could grant read-only access. The policy could grant, delete access. The policy could grant creation access, right? So users usually have policies attached to their groups, and users are part of multiple groups. Now, to be clear, whatever's the most permissive is typically going to win from an allow perspective. If someone puts a deny inside your policy, whatever's the most restrictive is going to win. So, just to say this is that if you are allowed to touch EC2 and then you have the same policy that says you're denied from touching EC2, denies always trump allows. So I said, I think I said it's most permissive. Let me correct that. It is whatever the most restrictive. So if someone explicitly denies you from something, you will never be allowed to do that thing until that deny is removed. So denies always trump allows. So explicit denies always trump explicit allows. By the way, if we don't attach policies to a user, they have no permissions. They got nothing. So, that's not very useful. Now, I already mentioned that you have an IAM username and password that's used for accessing the console. We already talked about the root email and password, which is the first one at the top, which said don't use it, right? That's used for account creation, not for daily operations. We already talked about access keys and IDs and secret access keys, because I said that's what's needed in order to grant command line access to AWS. And then we've got MFA, multi-factor authentication, which is just an addition, because the others are kind of like what you know to a certain degree, although I think the keys are kind of a little bit what you have. And then MFA is like a separate device of like, hey, what do you have? Do you have your device on you? Does it have the authenticator software on there? Can you read it? Do you have access to it? Good. Now here's a simple access key, secret access key kind of, notice this is an example key, by the way. Notice that if you run the AWS configure command line, which actually we'll do really quick, just so you can see this here. Obviously that's EC2 describe instances. Let's clear that. If I run AWS configure, and by the way, I've already run it, right? Note that I have a PBOH ending for my access key, and I have a PRV7, which I can't even see that actually. That's the most you will ever see of that key again, by the way. If I lose that secret key, I can create a new one, but I can't get the old one back. But notice it says PBOH under my access key ID up here, right? If I go back to the console and I click on users and look at Spartan Sage, which is my what my son calls me, and I go under security credentials, look at this access key down here, right? Notice that it ends in PBOH, just like the access key we were just looking at. I can get my access key ID all day long, but I can't get my secret access key except when I create it. So if I go in here and create an access key, it's going to display the secret key, the secret access key. I can only look at it at that time. If I do not download it or copy it, I will never see it again, right? So remember, this is the key that you use to run things on the command line. So I'm in the command line over here. Notice I said USEC2 and YAML, by the way. When I run this EC2 describe instances, it is basically pulling from this file that's located in my .aws directory inside my home directory. So there's a credentials file. Ignore that provider.tf. That's something I threw in there. But the credentials file is what contains my actual credentials. Now I'm not going to show that file because then you'll see my keys. I can't let you see my keys, right? And so just know that that access key and secret access key are required for command line access, right? And that includes SDK, right? Because remember, we went Java, Python, and .NET on the command line. We're using access keys and secret access keys. They're pretty much used for programmatic access, right? Now, groups are just places for us to stick users inside. So if we go back to my console, we take a look at the user groups. One, am I part of administrators, right? And it does actually say that Spartan Sage is part of administrators, right? So that administrators group has a policy attached to it that makes me an admin. Now, roles are slightly different because groups and users are easy for us. We've been using groups and users. We understand that. But here's a catch for roles. So if I go back to my IAM and I look at the roles, and let's say I look for a special role called Forester admin. I want you to note in the upper right-hand side, it says Spartan Sage and Forester. So if we look at this little account up here, it says Spartan Sage and Forester right up here on the right-hand side. Now, if I copy this account number and I click on switch roles, what will happen is if I click on the switch role button again, if I paste my account number in there and I type in the role that I want to switch to, let's choose a cool color. Let's do green. Notice in the upper right-hand side, what happens? I switched from Spartan Sage at 06767, that whole account number, right? But now I'm Forester admin. Now, the reason that I can assume that role is because I have permissions on the role that says anybody in this account can assume the role. Why? Because I'm the only one in the account, right? It's a demo account. Is that least privilege? No, no, it's not. My other production accounts, by the way, don't do that, right? That's just to highlight that sometimes I grant students access so they can assume admin permissions as they need to, right? So this is role assumption. I'm still Spartan Sage. I'm still that user. I'm still logged in as that user. I'm still using that, right? But right now, I'm actually logged into the console with an elevated set of permissions because I switched roles. So anything I do here, by the way, is going to show up as Forester admin as that role. And somewhere in there, it'll show that I assumed the role as well in the log file. Now I can always revert back to my user, but I just want to note also that I could actually make this another account. I could actually assume a role in another set of accounts, assuming that those accounts will allow my user to assume that role. You have to have the assume role permission in the account to assume the role in question, and the role has to allow you to assume it. So they call that a trust relationship, but the role will not allow just anyone to assume it. You have to say who can assume the role, right? I want to switch back. And now I'm back to Spartan Sage. Now, once I'm done doing whatever I need to do, you just saw that I just reverted back to Spartan Sage. Now, assuming a role, by the way, requires an API. It requires an API call, right? You have to call the API and say, I want to assume a role. And then what happens is that this thing called the secure token service actually returns temporary security credentials to you. And whether you are an IAM user or a federated user, you will assume those credentials, and then now you've got a role assigned to you. So the secure token service, by the way, is not talked about a whole lot, but it's the underpinning from when you actually go to assume a role. It's the one that returns a token with an expiration on it. You don't get to assume that role forever, by the way. I think the max is like 36 hours or something. Don't quote me on that. Anytime you hear numbers come out of my mouth, they're probably lies. So always make sure that you check the documentation before you start quoting it. I say that. That sounds horrible. But, you know, for accuracy. And the only reason for that is Amazon's changing this stuff all the time. Now, STS, I don't think has changed for a while. I just purely do not remember whether it was an hour or 36 hours, but yeah. Now, when you assign policies, just again, to reiterate this, policies can be assigned directly to users, can be assigned directly to groups, or they can go to roles. Now, resources are not really assigned policies, at least not identity-based policies. Thank you, by the way, Christian, for clarifying that. I couldn't remember exactly how long it was. So if you, by the way, decide to attach a policy to a resource or a service, you have switched from identity IAM-based policies, and now you are linked up into resource-based policies. And resource-based policies are slightly different than identity-based policies, which is what we've been talking about right here, okay? These have all been identity-based policies, which means you attach the policy to the user, you don't attach a policy to the service, right? So just something to keep in mind. Now, why do we use roles? Temporary privileges. So if you ever see an exam question that says, we want to grant Jose temporary access to somebody's account, the answer is roles. If you want to access a service, temporary access to a DynamoDB table, the answer is roles. Okay. All right. Any question before we peel back policies? All righty then. Okay. I think there are like 4 layers to policies now, if I remember correctly. There is the actual policy setting, which is the identity-based policies. There are permission boundaries, which allow you to kind of filter. And then there's SCPs, which allow you to filter at an organization level. So all these like boundaries now that you can set around your policies. So in other words, what do I mean by that? In purple here, you're showing that you can grant permissions either using the identity-based policies using IAM, which is what I talked about, or you can sometimes with only, I think it's like 5 services, you can attach resource-based policies. Like Amazon S3 is a great example. Amazon S3 will actually let you assign like policies to that service. I think OpsWorks does the same thing. SNS and SQS will also allow you to assign what's called resource-based policies. They look very similar to identity-based policies, but they also have a username in there So you can define which users can get access to like your S3 buckets or which users can touch SNS as an example. That's all on the I want to grant permissions. If you want to set up maximum permissions, like you want to set up boundaries around what permissions somebody can have, like for example, you want to say, look, you can't touch the quantum computing service, or you can't touch DynamoDB as an example, then you can either do it at two levels. You can actually set a permission boundary, or if you're using AWS organizations, you can set up what's called service control policies. So one of these, so granting permissions always operates at the account level. Let me say that again in case you missed it. Granting permissions always operates at the account level. You cannot do that at an organizational level. In other words, someone has to either go in and create a role, a user, or a group that grants access, that allows you to access the service inside of a particular account. You can restrict that using permission boundaries at the account level, or you can restrict that using SCPs at an organization's level. Organizations is one that eats lots of accounts, like multiple account management, right? So just know there's two levels of deny, of being able to restrict permissions, to set maximum permissions. There's only one level in which you can grant. So let me put this in a context for you. Let's say you're running an AWS organization and you've got 500 AWS accounts in that organization. If you want to give someone access inside of account one, you have to go into the account and either create a role, a user, or a group that grants access to services inside that account. You can't do it at an organizational level, not really. They have ways, by the way, with organizations for you to hop into an account to grant permissions, but you still have to get inside of an account in order to grant permissions to somebody. If you want to set maximum permissions, you could go in and deny someone access to quantum computing in account one, or you could go up to the organization level and say, look, nobody in any of these accounts can touch quantum computing. Right? So just know that with identity-based policies and resource-based policies, you grant permissions with permissions boundaries, and with SCPs, you can restrict permissions. Now, again, we talked about granting, right? The only thing that's kind of weird, though, is that these things kind of all work together. All right, let's take a look at this for a second. So identity-based policies, which are the ones that we were just talking about, are IAM policies, and they are attached to a role or user or a group. You can then go in and set resource-based policies on a variety of services, like a VPC endpoint, an S3 service, the KMS service. And by the way, this all uses AES 256 to encrypt data, right? If you're doing like server-side encryption or any of those kind of things, right? So just know you can set resource-based policies that also restrict access even further. Now, there are two general types of identity-based policies. So moving past permission boundaries, moving past SCPs for a second, moving past resource-based policies, there's two elements to identity-based policies. So, sorry, there's two types of identity-based policies. There's ones that you make up, and there's ones that AWS maintains for you that are public consumption, that are either service access, like you get access to an EC2 role, or you're a machine learning specialist, you are a virtual machine specialist, you're a container specialist. And so what they'll do is they'll have job function titles as well, like you're an administrator for AWS. And so when AWS does that, they maintain these policies. You cannot edit them, but you can mimic them if you want to, like if you want to copy them. I will tell you, most enterprises do their own custom managed policies. They might sometimes use the AWS managed policies, but usually only like the read-only ones, because they don't want to grant permissions out to everything, right? Now, every policy has three common elements and two optional ones. One, the policy must always have an effect. There's only two options. Are you going to allow something to happen, or are you going to deny something? Remember, if you deny someone access, no amount of allows will ever override that deny. You have to basically remove the deny before they can be allowed to do anything. Second thing is what action, what services can they touch? In other words, do they have access to the S3 API? Do they have access to the EC2 API? Can they talk to the DynamoDB API? If so, the third requirement is the resource. Is it any DynamoDB table? Or is it only the one labeled Rockstars, right? Is it the only one labeled My Favorite Christmas Movies? Like, what is the resource that they can actually do the action on? So those are the three common elements of an IAM policy, which is I need to know exactly whether I'm allowing or denying. So that's the effect. What can they do? So what verbs? So that's the action. And then what resource can they do the verbs against? Now, optionally, if it's an identity-based, a resource-based policy, they'll have a principal. And you might say, Michael, wait, don't we need a principal for identity-based policies? Because you just said resource-based policies need a principal. It's like I did. Resource-based policies need a principal because with identity-based policies, we are attaching the policy to the principal. Let me say that again in case you missed this. With an identity-based policy, I am attaching the policy to the principal. It's attached to a user or a group or a role. So I don't have to define the principal because the policy is attached to the principal. That's with identity-based policies. With a resource-based policy, I actually have to specify who can do what because this policy, if it's resource-based, is attached to a service. So like if I attach the policy to S3 and I say, hey, by the way, Sean, Vinod, and Masood can all manipulate this S3 bucket, I have to declare that somewhere and that gets declared in the principal. But if I'm like, hey, I don't want to do it that way, I just want to attach a policy to Sean, Vinod, and Masood, then what I'll do is I'll just attach the policy. And because the policy is there, I won't need to define the principal. That's the difference between identity-based policies, which are attached to the principal, and resource-based policies, which are attached to the resource or service. Now, conditions, by the way, can exist on either identity-based policies or resource-based policies. Conditions, by the way, are fun. Conditions do things like, Timothy can only access this bucket if he's coming from the corporate IP address, right? Heather can only touch this bucket if it's between, December 1st and February 1st, right? Chris can only, basically look at this bucket if everything he does is encrypted. So he has to use SSL TLS, right? So those are the kind of conditions you can actually set inside of a policy. Conditions are usually set to enforce some kind of security boundary. Like this user expires in 2 months, or you better be coming from VPN, not your home network, right? That kind of thing. I want you to take a minute and look at the bottom. See where the effect is allow, the action is DynamoDB, star, S3, star, and then the resource is an explicit DynamoDB table and an explicit bucket and an explicit bucket /star, which is its contents. So I want you to look at that and tell me where the effect is, where the action is, and where the resource is. Christian, are the book notes on this slide terrible? Sorry, yeah, I haven't seen them actually. I'm gonna have to look at it.
The book notes are the slide. So the slide, and then they have the code from the slide. That's all it is.
Yeah, sweet. Yeah, that is terrible actually. They could at least just record what I'm saying and put it in there. I'm just kidding. No one wants to record what I'm saying. Anyway, you see the 3 sections there. Notice, by the way, there's no principal because this is an identity-based policy. It's not a resource-based policy. And notice that conditions are optional. So this is an explicit allow, and then here's an explicit deny. By the way, if I put these 2 sections on the same policy and attach them to a user, guess what happens? User gets nothing. Remember, denies always trump allows. Always. Okay, here's a condition. This basically allows the user to start and stop instances, but it says the owner tag must match the username who is attempting the call. So for example, if I didn't actually tag that resource where owner equals Spartan Sage, couldn't stop and start that resource, could I? Conditions are optional. So yeah, so Sean just actually made an interesting observation, which he said denies take precedence, right? Here's a great example, by the way. Bottom line, has someone been explicitly denied anything? Because that's going to be the first thing. No, they're not explicitly denied. Okay, great. Have they been explicitly allowed to do something? No. Okay. Well, then they're invisibly denied. But know that if any of those conditions are actually true, they've been either explicitly denied, they're denied. If there's no explicit deny and they've been allowed, they're allowed. If there is neither an explicit deny nor is there an explicit allow, then the implicit or invisible deny takes over. So as he stated, denies, explicit denies take precedence every time. Now that's us looking at an identity-based policy that has conditions in it. What about a resource-based policy? Well, resource-based policies, notice that there is a principal listed there. So for the first time, we're seeing a principal inside of a policy statement. Now, this is allowing someone to put an object inside of the contents of this specific folder on this specific bucket with this specific account. Now, note, by the way, that this is attached to the S3 bucket and that it will actually assess both the identity-based policies of the user who is executing the request, and it'll look at the resource-based policies of the service that's being accessed. As a general rule of thumb, if you can do it inside of IAM, you're going to do it inside of IAM. You're not going to do it inside resource-based policies. There are a few things that you can only do inside of resource-based policies, right? But just know that for the most part, we try to avoid that, okay? For example, you can attach, and by the way, S3 buckets, SNS, SQS, KMS encryption keys, VPC endpoints, those can all have resource-based policies. I think OpsWorks can too. I haven't looked at that list recently. I think they whittled it down. So I know most of the services that predated IAM, which I don't think came out until 2011, most of those services that were already there, they actually do accept resource-based policies instead of identity-based policies. But some of them got replaced. Like they retired some of those services. No, they didn't retire some of the services. They made it so that some of the services that only accept resource-based policies will now accept identity-based policies. So now they all accept both. Okay, so let's say, by the way, you want to like review permissions. Just know that the access advisor, which let's go take a look at the access advisor. Take a look at my user. So there's an access advisor tab underneath every user, and it will basically tell you who and what has accessed what over any given period of time. So for example, you can see that, well, apparently I was messing with a secure token service and was looking at some APIs and was futzing around with Cloud9. So you can actually see what I access. That's the access advisor, which is not to be confused with the next thing, which is called the IAM Access Analyzer. Now, the Access Analyzer is going to see if your account, like who has access to your account, right? So unlike the Access Advisor, if we look at this, this has its own section inside of IAM. If we click on this, that's lightning fast. This is going to tell you which external principals have access to your account. And that includes, by the way, wide open S3 buckets, right? If I was doing single sign-on with somebody, right? Everybody who has access to your account, you can see that inside of the Access Analyzer, not the Access Advisor, the Analyzer. Now, this was all about granting permissions to either via identity or via resources, and figuring out how to, look at that identity, those grants. Permission boundaries are a little different. Permission boundaries operate at the account level, just like policies do, but it's an advanced feature for using like a managed policy to set the maximum permissions that an identity-based policy can give either a user, a group, or a role. So think of permission boundaries as a filter that will prevent you from over permissioning somebody. So if someone has an identity-based policy and they have a permission boundary, what will happen is that whatever the permission boundary allows to happen is what will happen no matter what the identity-based policy says, right? So it limits the user's permissions. So for example, you could grant someone admin rights and then just pare them down and say, well, they can't do this, this, and this, right? Now, I like the thought of that. At the same time, why wouldn't I just pare the user's permissions down to explicitly what I want? Well, what if you were basically allowing people to create other users, but no matter what that user did, they couldn't grant them permissions beyond a certain scope? So it's a way for you to create admins who can in turn create other users, but maybe those users never get more permissions than what the permission boundary allows, right? I don't know. I still think there's other ways to solve this, but I understand that there are use cases where this is useful. By the way, note that with identity-based policies on the far right-hand side, you can grant or deny, but with permission boundaries and with SCPs, which we haven't even talked about yet, those are service control policies, you can deny someone access. So just know there's many ways for you to scope a user down, even if you've given them a broad swath of access. You can scope them down to whatever permission limits you need. As a general rule of thumb, I mainly use identity-based policies or SCPs. I don't really use permission boundaries really at all, honestly. So I'll just use SCPs to limit scope if I want to limit someone's access to an entire thing. But I mainly work in companies that have an organization already, right? So I don't really work in companies that only have like a single account. So there's no necessarily additional cost for using organizations. So I'm not sure why people wouldn't use organizations if they had multiple accounts. Okay. Let's talk about federation then. Any questions about either identity-based policies, resource-based policies, permission boundaries, or SCPs? Okay. Let's talk about federation, like Active Directory as an example. So federated users are basically users that do not have, AWS accounts. And by the way, these could be federated applications, but you want to grant them access to AWS for a limited time. This is really useful for not, especially if you can authenticate with an external service like a ping federated and Okta Active Directory. Even in some cases, like a web identity, like Google or Amazon, right? This could be Open LDAP, Apple Open Directory, Microsoft's Active Directory services. And what happens is that this is to provide short-term security credentials with a broker in a store that's external, like maybe in your corporate data center, right? And so what happens is that there's a trust relationship created between AWS and the service. And then when the user logs into the identity broker, the identity provider, it will then actually retrieve credentials from AWS, return them back to the user once the user's authenticated. So authorization comes from AWS and the trust relationship, but authentication comes from the data store. So you have to log into the store first, right? Heather, I saw your statement, by the way. It is lots of info. So here's federation without, like, for example, like, let's say single sign-on, right? So in this case, what happens is that everybody has to log in separately to all their stuff, including the AWS accounts. If we throw in a service like AWS SSO, what ends up happening is that you can now use like log into Active Directory and then get access to all of your AWS accounts. You could even get access to things like Salesforce and other federated accounts just because you've now logged into single sign-on, and there's a trust relationship between all of these services and the single sign-on service, right? So just know that anything can hook into single sign-on that supports SAML 2.0. So whereas you can actually hook in anything that supports OIDC or SAML 2.0 into AWS, for single sign-on, it supports SAML 2.0 mainly. This does not cost extra, by the way. No cost for this. So this is just a general like statement that you can actually federate Active Directory and other third-party federators or identity brokers with AWS. Okay. Moving beyond the possibilities of federating the AWS database with your own system is how do we manage multiple accounts? You've heard me talk about this several times already where I'm like, yeah, what if you walk in, you've got 700 accounts? How are you going to restrict those? How are you going to control access to those? How are you going to enforce security policies and compliances? How are you going to have visibility, right? You already get consolidated billing, but how do you make it so that as an organization, these 500 accounts work in tandem, right? This is where organizations come in. And then we'll talk a little bit about SCPs, which is like a part of organizations. And then, a notable mention for Control Tower, which is a really organized way to create these accounts. Now, why would you use multiple accounts to begin with? I'm just going to say this. It's a great way to do billing, security isolation, project isolation, and to maintain many security and compliance controls. This is great if you've got a lot of teams inside your organization who are launching many products and they need to be independent from each other, which honestly is most teams. So without organizations, what's going to happen is that for every single account, you're going to have to replicate these policies that you're creating. That's not necessarily efficient or fun. If you put all these accounts inside of an organization, what ends up happening is that you can actually organize these accounts based on what's called organizational units, which works just like Active Directory. And so you can stick them under the project A, prod, project A, non-prod. In other words, you could actually apply policies at different levels of organization reflective of how you want those policies to be applied. You might be tighter with production than you might be with non-prod. And that's the way it should be. Production should be a little bit more locked down, right? And so with these like management layers or organizational units that you create, you can apply those service control policies, which can restrict access to certain services. So for example, here at the SCP, they've gone in and said, look, you can grant access to all these services, but you're denied access to these services. If that matches what's over on the identity-based side of things, then guess what? You get to grant access to these services. Now, remember, only the things in purple on the right-hand side at the account level, those are policies. Those identity-based policies, they grant permissions. The blue stuff on the left can only deny permissions. It cannot actually give somebody access. In order for that to happen, you actually have to have an identity-based policy inside of the account. So remember, permission boundaries and SCPs act as filters. They cannot grant permissions. They can only allow you to have permissions. Okay. Here's an example where EC2, we granted it, full access, right, to EC2 using an SCP, but it's restricted to a single region. And what happens is that policy is applied to that organizational unit and it flows down to all of the accounts. Now, by the way, to mention this, because I did say this was going to get notable mention, is that Control Tower is a way for you to set up a new secure multi-account AWS environment where you can actually like vend out accounts like a vending machine. And what it is it'll basically help you like pre-build your like organization, including a security and auditing account, so that it'll capture all the logs from like CloudTrail and CloudWatch and stuff like that. So you can actually just set up your entire enterprise to use this Control Tower right off the bat. This also will grant you single sign-on, and it'll also, by the way, use CloudFormation stack sets, and it will turn on the service catalog, and the service catalog will allow you to vend out services to these provisioned accounts. So it basically is going to enforce governments, do invisibility, like, get continuous visibility, do the whole 9 yards. And so, Hunter, I would say, can you compare organizations to user groups? Absolutely. I think that's actually a good analogy, is that think of organizations as a user group for all of your like accounts. One thing to note though is that you can only have one organization, like you can only belong to one organization. So if you're an account and you want to belong to multiple organizations, you can't do that. Unlike users and user groups, users can belong to multiple groups. That's the real distinction, is that otherwise this works very much like a user group, is that accounts are now part of an organization. One thing that's cool about this is that, and I think I have Control Tower enabled in my demo account. Let's go see. One thing that's cool about this is that I've got 3 accounts instead of 2 organizational units, and you actually turn on to preventative and detective guardrails, right? Now, what's funny is that I can actually come in here and I can actually like dispense an account. Actually, let's go to organizations. So for example, if I'm in organizations and I want to add an AWS account, I can literally either create an account or invite an existing AWS account, right? So I can actually use this to just create new AWS accounts. I could create 500 accounts here. The only thing I would need is a distinguished email for each one. So just something to be aware of is that you need a distinct email for each AWS account. And the way I get around this, by the way, is if we actually go look at my, notice how this says IT Amazonian Student 1. If you're using Gmail or Yahoo or MSN or Live or Outlook, if you put a plus after your name, because it's IT Amazonian at gmail.com, if you put a plus after your name, anything after that plus is ignored, but it looks like a distinct email address to these systems. So that's how I get around this, is I keep adding pluses to my base email address. It all, by the way, goes into my IT Amazonian at Gmail inbox, but it looks like a distinct email to AWS. So that's what Control Tower does, is it sets up a best practice multi-account environment that follows the well-architected framework best practices, including security, reliability, et cetera. Okay. Questions here? Questions of any type about either IAM, users, groups, and roles, identity policies versus resource policies, questions about just the general concepts around single sign-on and using SAML 2.0 or OIDC, or any questions about Control Tower, organizations, and how that functions. Okay, let's ask our first question. Which of the following can be attached to a user, a group, or a role? So what can be attached to a user, a group, or a role? Good, identity-based policies, right? Resource-based policies can only be attached to services. STS cannot be attached to anything. It's a secure token service. And security groups are stateful firewalls that are always attached to a network card, usually inside of an operating system like an EC2 virtual machine. All right, which policy type is not assigned to IAM security principles and can grant permissions to access a specific service or resource? Okay, so it cannot be assigned to a security principal, which means it cannot be assigned to an identity. So it's not going to be identity-based policy, right? But it can grant permissions to access a specific resource. So that sounds like a resource-based policy, right? Service control policies and permission boundaries can never grant you access. They can only allow you to have access. They don't grant it. They can allow you to have access to it. Which of the following are benefits to using roles? Let's select two. B and D, right? Good. So roles can do cross-account access. That's true. And you give temporary permissions. Remember, roles are specific to temporary permissions. AWS wants you to hang on to that and remember that deeply. Other questions? The root user should not be used for daily administration of your AWS account. Is that true or false? Woo. Okay, good. I did actually make a big enough fuss about that. It's good. Yes, that's true, right? You do not want to use the root user to be used for daily administration for your AWS account. What can simplify logins for customers using Active Directory, AWS accounts, or third-party services, right? What can we use to synchronize all of this? Good, you all answered single sign-on, so I think you were paying attention. Perfect. All right, that's the end of module 2. Any questions in any way, shape, or form about IAM, all its little vagaries there, or anything around organizations? Okay. All right, well, we only got about 10 minutes left, so I'm going to keep going here for just a minute. We're going to move on to module 3, networking.